Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P2251, indicates a high voltage condition in the vehicle's AF sensor circuit for Bank 1, Sensor 1, which applies to all Honda Accord models from 2008 to 2012, except the partial zero emissions vehicle, PZEV models. The AF sensor, also known as an air-fuel ratio sensor, is critical for measuring the ratio of air to fuel in the combustion process, allowing the engine control module, ECM, to optimize engine performance and emissions. Located typically in the exhaust manifold, the AF sensor plays a vital role in ensuring the engine runs efficiently. If the sensor detects a voltage reading outside the expected range, it triggers DTC P2251. This condition needs immediate attention to prevent poor fuel economy, increased emissions, and potential engine damage. The error associated with DTC P2251 pinpoints the rear air-fuel AF sensor for Bank 1, commonly found near the exhaust manifold of the engine. This sensor's main responsibility is to gauge the air-to-fuel ratio entering the engine, ensuring proper combustion. By sending this information to the engine control module, ECM, the vehicle can adjust the air and fuel mixture for optimal performance and minimal emissions. If the sensor detects high voltage faults, it could indicate wiring issues, sensor failure, or faults within the ECM itself that need immediate troubleshooting. Proper diagnostics should also consider location-related factors, such as heat exposure, potential damage from road debris, and corrosion in connectors. Several factors can lead to the triggering of DTC P2251. The first potential cause is a faulty air-fuel AF sensor itself. Over time, sensors degrade due to extreme heat or contaminants within the exhaust, affecting their ability to send accurate voltage signals. Second, wiring issues can also lead to high voltage conditions. Frayed wires, poor connections, or corrosion at the terminals can disrupt the signal flow between the sensor and the ECM. Lastly, an underlying malfunction in the engine control module, ECM, or powertrain control module, PCM, could be the root cause. This could point towards software issues or internal component failures that may require reprogramming or replacement. Comprehensive diagnostics should address each of these possibilities methodically. The manifestation of DTC P2251 can lead to several noticeable symptoms. Firstly, poor fuel economy is one of the most common indications, as the erroneous readings from the AF sensor may cause the engine to run rich or lean, leading to inefficient fuel usage. A second symptom is a rough engine idle, which can arise from improper fuel mixture, affecting the engine's smoothness during idling. Additionally, increased emissions may occur, leading to potential failure in emissions testing. The vehicle might also display warning lights on the dashboard, such as the check engine light, indicating a need for immediate assessment. It's critical to address these symptoms promptly to avoid further complications to the vehicle's performance and compliance with environmental regulations. The first troubleshooting step for DTC P2251 involves turning the ignition switch to the on-to position. This powers all the electrical systems without starting the engine. Once the ignition is on, the next step requires clearing the DTC using the Honda Diagnostic System, HDS. Clearing codes resets the vehicle's computer, allowing the technician to see if the DTC returns after the next step. The engine should then be started, and it's essential to hold the engine speed at 3,000 RPM for a specific duration until the radiator fan activates, which indicates the cooling system is functioning properly. After allowing the engine to idle for 2 minutes, It sets the stage for the next diagnostic steps, which may confirm if DTC P2251 is persistent. Following the initial procedures, the next step involves checking for any pending or confirmed DTCs with the HDS. This crucial diagnostic tool allows the technician to view live data and any trouble codes that may be present. If DTC P2251 is indicated again, it confirms that the sensor is still experiencing issues that need addressing. This step also involves being mindful of any other stored codes, especially if DTC P0134 or P0154 is present, emphasizing the critical nature of following procedure order in diagnostics. If the DTC is not present, it may suggest an intermittent failure, prompting the technician to inspect for poor connections or loose terminals at the AF sensor and ECM/PCM, reinforcing the importance of thorough inspections in vehicle diagnostics. The third troubleshooting step involves turning the ignition switch to the lock 0 position to safely disconnect electrical components before proceeding with further diagnostics. This ensures that no power is flowing, which protects both the technician and the vehicle's electrical systems. Next, the SCS service check signal line must be jumped using the HDS, allowing for additional monitoring of the vehicle systems under different states. After preparing the environment for testing, the AF sensor, sensor 1, 6P connector, needs to be disconnected carefully. It is essential that this disconnection is done without damaging the connector or wiring, as maintaining the integrity of the electrical components is critical for accurate testing and reliable diagnostics. In this step, the technician must disconnect the ECM/PCM connector B to isolate the control module from the A/F sensor circuit. This makes further testing of continuity between connectors imperative for diagnosing faults in the wiring. A continuity test between the A/F sensor, sensor 1, 6P connector terminal number 4, and ECM/PCM connector terminal B13 or B14 is crucial. This will identify if there is a break or short in the wiring harness. For 08-09 models, the specific terminals are designated for accurate checks, while for 10 to 12 models, slightly different designations apply. This thorough diagnostic approach emphasizes the need for precision and attention to detail in the vehicle repair process to resolve the DTC efficiently. Once all the troubleshooting steps have been completed, it is vital to conduct a final verification before closing the repair case. This involves rechecking for the presence of any DTCs using the HDS to ensure that DTC P2251 has been resolved. To further validate the repair, the technician must verify the proper operation of the AF sensor. This may include live data monitoring and inspecting the response under various operating conditions. Finally, a test drive of the vehicle is crucial to confirm that the system operates correctly under real-world conditions. If issues persist, deeper investigation into the wiring and ECM/PCM may be necessary. This step guarantees that the vehicle is restored to optimal functionality. Preventive maintenance is an essential aspect of vehicle health, particularly for systems related to emissions and fuel management, like the AF sensor. Regular electrical inspections help identify any signs of wear or corrosion that could compromise connections. Implementing routine tests of the AF sensor aids in early detection of performance issues before they escalate into DTCs. Monitoring the vehicle for consistent patterns in DTC storage can also preemptively address potential issues, allowing for proactive repairs rather than reactive measures. This preventive approach enhances the vehicle's efficiency and reduces long-term repair costs, emphasizing the importance of maintenance in vehicle operation. In conclusion, troubleshooting and resolving DTC P2251 requires a systematic approach that emphasizes understanding each component's role in the system, addressing potential wiring issues, and ensuring secure connections to both the AF sensor and ECM is crucial to resolving high-voltage conditions. Regularly testing sensor performance is equally important to maintain optimal vehicle operation, minimizing future emissions, and improving fuel efficiency. The importance of following diagnostic protocols cannot be overstated, as they give a roadmap to identifying and rectifying issues effectively. Ultimately, well-informed repairs not only restore performance, but also enhance driver satisfaction while ensuring compliance with environmental regulations. Please like and subscribe to the channel. See you next time.